All right, guys, welcome to the 3-3 notes, proofs with parallel lines. And today's lesson is all about the converse, party people. The theorems we're going to talk about today are just the converses of the ones we talked about in the last section. Big key here is we do not know the lines are parallel. Are they parallel? Not sure. Look at the conditional statement. If two lines are cut by a transversal, so blah, 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 then the lines are parallel. So if you know that the corresponding angles are congruent, then we can conclude the lines are parallel, as opposed to the last section where we said, hey, the line's parallel, so then you could conclude the angles were congruent. So the converse also true. All right, now in the solving for x world, like example 1, it's the same for you as far as how you're going to solve it. The wording of the question is just different. Find the value of x that makes the lines parallel, instead of, hey, the lines are parallel, find the value of x. So no problems here. The setup is exactly the same. They're corresponding, so you'd want them to be equal to each other for these lines to be parallel. So x is 20. That is the value of x that would make the lines parallel. All right, pause the video here and try the monitor progress. All right, back again. All right, so is there enough information to conclude this? Well, let's see. Next to a 105 would be a 75 based on a linear pair postulate. And then, aha, look at that. I have corresponding angles that are congruent. So yes, corresponding angles converse. Same thing. All right, so now here are the rest of your converse theorems. Alternate interior, alternate exterior, and consecutive supplementary, of course. The other two congruent. And again, it's the converse of all of them. So if two lines compare each other, so the alternate interior, then the lines are parallel. So we don't know the lines. You won't see the arrows on these lines because we don't know they're parallel. Once you'd have this information, or this information, or this information equaling 180, then you would be able to say the lines are parallel. All right, proving theorems about parallel lines, example 2. Let's prove the alternate interior angles converse theorem. So now we proved the normal theorem last section that, hey, if the lines are parallel, then the alternate interior were congruent. Now in this one, look what happens. The given and the proved switch places. So now we're like, okay, we are given that 4 is the same as 5, all right? And now that should be enough information for us to say that the lines are parallel. So let's see how we're going to do it. Main key here is you can't use your theorems of like, hey, let's see, 1's the same as 5 because they're corresponding angles. You can't say that yet. You're trying to show the lines are parallel. You can't use the parallel theorems. What you can always use, though, is our old friend vertical, right? Vertical does not rely on parallel lines. Let me say that again. Vertical does not rely on parallel lines. So you can always start out with, well, not start out with that. Of course, you know what you're going to start out with. The given information. And then now brainstorming this, if you, they kind of helped you out here with the angle 1. So we know that 1 and 4 are congruent because they're vertical. So we're going to go with that next. And now if 4 is 5 and 1 is 4, then you know that the transitive property is coming. 1 is 5. And so now, see what you've done? You've proven that 1 is the same as 5. So therefore, if 1 is the same as 5, that's important stuff. 1 is the same as 5. Therefore, the lines have to be parallel. This 1 is the same as 5 gives you the right to say the lines are parallel. And guys, here's the key to these types of proofs. If you're trying to prove lines are parallel, you're going to have one of the converse theorems as your final reason. Again, if you have to prove lines are parallel, the converse of one of the 4 theorems, whether it's alternate interior, exterior, corresponding, or consecutive. All right. Example 3. determining whether lines are parallel. In the diagram, R is parallel to S, and angle 1 is congruent to angle 3. Prove that P is parallel to Q. All right, so let's see here, guys. In the diagram, R is parallel. So we know that these two are parallel. So that's important. That means all the relationships from section 3.2 will actually apply. We don't know that these two are. We're trying to show that. So it's like, okay, what am I going to do about this? Well, since it's given that these two are parallel, I can go back and forth with all my relationships between R and S. So like, well, let's see. I know that 1 would be the same as 2 because they're corresponding, and that's legal because it's given. All right. They also told me that 1 was congruent to 3. That was given up here in this information. So now, if 1 is the same as 2, and 2 is the same as 3, then of course that's going to prove that these lines are parallel because of the converse of alternate interior angles. So now let's make it pretty. And of course I'm going to start out with my statements, reasons, the given was that R parallel to S and 1 congruent to 3. So that will be here. I'll just put them in the same. It's all given. All right, so now, well, what did we say? We said that we can go back and forth. Since R was parallel to S, I'm allowed to say that angle 1 is congruent to angle 2 because they are corresponding. And then that allows me to say that angle 2 is congruent to angle 3 by transitive property. 1 is 3 and 1 is 2, then 2 is 3. And now since I've established that, now I can say that P is parallel to Q. And again, it's the converse of, now what are 2 and 3? That's what goes here, alternate interior. All right. So again, that's what you're looking at. You want to make sure you end with converse of something and look back up to the step before to see which converse you'll use. In this case, it's the alternate interior because 2 and 3 are alternate interior. All right, pause the video here and pick it back up when you are ready after you've completed this 2-column proof. All right, so hopefully you got a little something like this, my friends. You've got your given, and then the brainstorm concept here is we know that 1 is congruent to 3 given. And we also know that we have the parallel lines with R and S. Sometimes that'll be up here. In this case, it's not. All right, so where we want to go from there, since R is parallel to S, we got all of our relationships going back and forth between R and S. So that allows us to say that 1's the same as 2 corresponding. And then if 1 is 3 and 1 is 2, then 2 is 3 from the transitive property. And now once we say this, 2 is the same as 3, then we can say that their lines are parallel because of the converse of alternate exterior. And one of the big errors here is to put this step is to write it as alternate exterior. Be careful, it's not yet. You didn't establish that the lines are parallel yet. Once you say the lines are parallel, then you can say all the relationships that exist between J and K actually are work. But until that point, You don't know. So use other things. We were allowed to say this corresponding because it was between R and S, which we knew were parallel from the start. All right. Monitor progress here. We got if you use the given diagram below to prove alternate exterior converse, what given and proof statements would you use? All right, so pause the video here. This is a good one to practice and pick it back up when you're done. All right, so here we go. The given, in this case, are the two angles that are marked congruent. So angle 1 congruent to angle 8. And we would be trying to prove that J is parallel to K. Right, so since we're proving the converse, you know that the prove statement is going to be lines being parallel. All right, using the transitive property of parallel lines. So this should be pretty simple. You know, if you got two parallel lines here, and then these two are parallel, then the first and the last are parallel. And you can use it just the same way we did with transitive property. You have 115, and then you could move the 115 down there. So then you'd have 115 plus angle 8 has to equal 180. So angle 8 would have to be 65 degrees. All right, that's a wrap. Peace.